All right, so here's your review page for your quiz next class. So we'll take a look at this key and get you some good practice. All right, Carter threw a bottle of water out into the window, out the window of his bedroom to his friend below. The data in the table represents the height of the bottle as a function of the distance from the house. Calculate a curve of best fit to model the path of the water bottle. So we'll go ahead and go to our graphing calculator, and we'll go to Stat, Edit, and then we'll go ahead and type in the distance from the house, 1, 2, 3, 4, 5 feet. The height of the water bottle is our output, so that'll be 15, 17, 16, 12, and 7 feet. We want to go to second stat plot, and we want to turn the plot on. Then we want to go to zoom, and we want to choose choice 9, zoom stat, and then it's clearly a quadratic model. So we'll go ahead and run the regression, stat, calc, quadratic regression, and we'll have vars, y vars, because he's a fun guy, put the equation into our y is equal to screen for us. So first of all, we'll do our sketch here where we have Carter throwing the water bottle out of his window. Our equation of best fit is negative 1.21x squared plus 5.19x plus 11.2 is equal to y. All right. If his friend misses the catch, how far from the house does the water bottle land on the ground? So what we're looking for is this distance here. Remember, this is our distance from the house, and this is our height of the water bottle. So we're looking for this 0 here. So when I look at my graph, I really can't see, so I'll probably need to adjust my window. I'll go to my window, and I'll have my x minimum be negative 1. We can make my x max go a little higher. We can have my y minimum be negative 1, and my y minimum go a little longer. So what I've done is I've expanded my window just a little bit so I can see my beginning, my middle, and end of my story. This is what I'm looking for here. Stat calc. Oh, that's not what I want. I want regular calc. Second calc. And I want to find my 0. And I'm going to go ahead and put Mr. Blinky down by the intersection to the left and right. As soon as my y's go negative, I'm okay. So what this tells me is that at 5.85 seconds, that's when the water bottle hits the ground. How high did the water bottle go is my next conversation, and that here is going to be my maximum or my vertex. So I'll go to calc. I'm looking for my maximum, and I want to go ahead and put Mr. Blinky back to the left. And then to the right. And the maximum height was 16.74 feet high at 2.14 seconds. So how high did the water bottle go? 16.74 feet. What is the height of Carter's window? Now what we're talking about here with the height of Carter's window is where the bottle starts. where it is at time 0. So if I look here on my graphing calculator, that's going to be how high Carter's window is, because you threw it out the window. So his window is about 11 feet off the ground. So 11.2 feet. If his friend caught the water bottle at a height of 4 feet, how far was he standing from the house? So let's talk about what this means at our sketch. If the friend caught the water bottle here at 4 feet, I want to know how far he was standing from the house. So I can go ahead and go to here and look at what happens when this is equal to 4. There we have the friend that's 4 feet high. So I'll do this intersection. Second calc, I'm looking for the intersection. And Mr. Blinky's on my first curve. And I say, yep, that's right. And he's on my second curve. And I say, yep, that's right. And he tells me they intersect at this distance from the house. So 5.37 feet. All right. Next problem. Last year, 5 randomly selected students took a math aptitude test before they began their statistics course. Write the equation of the line of best fit for this data. Okay, here we go. We're going to go to Stat and Edit, and I'm going to arrow up to clear and hit Enter my previous data. All right, a score of 95, 85, 80, 70, and 60. Does it have a relationship with a score of 85, 95, 70, 65, and 70? So I need to turn my plot on. It's already on. So zoom choice 9 is Stat, and what the heck? That doesn't look like anything much at all, does it? I'll double check my data and see if I did it right. 95, 85, 80, 70, 60, 85, 95, 70. It looks good. So when I write the line of best fit, Stat Calc, it'll still do it for me. It'll be a lousy line of best fit, but it'll still do it. All right, so my equation of my line of best fit is y is equal to 0.64x plus 26.78. If a student made an 82 on the aptitude test, what grade would we expect her to make in statistics? I can go to my table of values. A quicker way for me to get to 82 is to have my table set start there, and then I can go to my table. I would expect her to get a 75.58 on the test, but keep in mind that was not a very good graph. I can tell that by running the R correlation. I can go ahead and go to my catalog, go down to diagnostic on, choose it, enter to choose it, enter to run it, redo my statistics, second calc, LinReg, a 69%, not a good grade on a test, not a good R correlation. We'll make a note on that of a 69% R correlation. Not a very good one. So the calculator doesn't think for us, but it sure will do what we say. All right, let's take a look at the next page. Using the data, compute and write a line or an equation of best fit to round all answers to hundredths, to decimal places if needed. All right, so you turn off the video, you enter the data, come back and we'll see if we match. All right, how did we do? I knew I only had to run the LinReg for both of these because right here it said the line of best fit, and both of those models looked linear to me when I rounded them. This most recent one had an R correlation of 99%, so that was pretty good. It was a pretty good equation. All right, moving on to 3. This one's different because we have to get the graph. We have to get the data from the graph. So when I look here, I have my weight in pounds, and I look at this, it's definitely linear. So we'll go ahead and we'll enter in the time in weeks in my X. So I'll go to Stat, and I know I'll go to Edit, and I'll clear out last question's data. And my X values are 0, 1, 2, 3, 4, 5, and 6. At 0, I have 180 pounds. At 1, what would you say, 178? Here, we'll call that 176. Week 3 is 175. 4, 171. 5, 170. 6, we'll call that 168. Now, if you guesstimated a little bit different from me, our graphs might be a little far off. Reg. All right, the equation of best fit. So it looks like if this is me losing weight, I lose about 2 pounds every week, and I started at 180 pounds. If I want to know my weight for 10 weeks, I need to go back and have VARS put that equation into my calculator. So I'll go to Stat and Calc, then Reg. I'll do VARS, Y VARS. He's a fun guy. He's going to put that equation into my Y is equal to. I can go and look at the graph. Ooh, I never zoom fitted it. That's okay. I'll go to the table and I look at 80 weeks. If I want to get there faster, second table set, I can start the table at 10 and then go to my table. Looks like after 10 weeks I'll be down to 159.75 pounds. Alright, here's a chart for a family of the number of gallons of milk for the family size. So we'll go ahead and pause the video, you enter the data, and check back in. Alright, so I have my data in and I ran my regression and I have my equation. It says use your model to predict the number of gallons for a 7-member family. So I'll go back to Stat and Calc and I'll ask VARS, Y VARS, because he's a fun guy, to put that equation into the function screen, which means then I can use the table of values and I can look for a 7-member family is going to be using about 6.15 gallons of milk. All right, our National Fitness Award qualifying standards list the following times for the 1 mile run. Write a prediction equation that relates age to the time for the 1 mile run. All right, so we'll go to Stat again and Edit and arrow up, clear, enter, arrow up, clear, enter. And age 6, 7, 8, 9, 10, 11, and 12. 6-year-olds, 12.4. 11-year-olds, 11.7. 8-year-olds, 11.1. 9-year-olds, 10.5. 10-year-olds, 9.8. 11-year-olds, 9.3. 12-year-olds, 8.7. When I run the regression for the quadratic VARS, Y VARS, fun guy. My curve of, or my line of best fit. Ooh, I ran a quad, not a line. Let's try that again. Stat, Calc, 4, VARS, Y VARS, fun guy. That's better. All right. My equation of my line of best fit is y is equal to negative 0.61x plus 16.03. Use the line of best fit predicted time for a 16-year-old. So we'll go ahead and go to our table of values, and I'll go down to a 16-year-old. Looks like 6.2-ish. That's pretty close. So we'll go with that. All right, study, study. Memorize those calculator steps. Good luck.